Okay, I'll back up. To find the area of a sector, which would be this whole pie shape, we're going to take the fraction the sector is, which in this case is 1/6, times the area of the whole circle. And the area of the whole circle is 64 pi. Multiply that by 1/6. This is the same as dividing by 6. And we'd have our area of the whole sector. If we want to find this area that's shaded, I've got to take the area of the whole sector, which is this, and subtract the area of the triangle. Okay, so you're going to see a lot of chapter 8 coming back here, because we're going to have to find areas of triangles, special triangles. As an example, to find the area of this triangle, if we know this is 60 and we know this is 8, well, what's that formula for the area of a triangle? 1/2. 1/2 base times height. Okay. Well, I can figure out the height because this becomes a 30, 60, 90. And the opposite of the 90, so that means that this piece is what? This is 60. Opposite of the 30 is what related to the hypotenuse?
Square root.
No.
X.
Okay, so what is the value?
8.
No. It's half the hypotenuse.
The whole work.
And the area, the side opposite the 60 is 4 squared to 3. Right? And so I know that this is 4 and this is 4. Right? So the whole thing is 8. So my base is 8. My height is 4 squared to 3. And I'm going to divide that by 2. 1/2 base times height. So 8 times 4 is 32 divided by 2. So the area of this triangle is 16 squared to 3. So I would find the area of the whole sector, which is what I've got here. And I would subtract this, and I would end up with a decimal. Just to write that in for the answer. Okay, so finding the area of the wedge, if you will, actually the whole sector, is pretty easy. You're going to just figure out what fraction of that is the whole circle, and then multiply it by that fraction with the area. It's finding that little sector up here that's a little more difficult because you've got to subtract the area of the triangle. So if I go to the video check, to find the area of the circle, of the sector, you would find the area of the circle and multiply it by 1/6. Here, I just asked what the area of the triangle was. So let's do that one. 120 and 24. So I could break this into, this would be 60, right? If I just split this in 2. This is 30. So the side opposite the 30 is half the hypotenuse. And the side opposite the 60 is that. So I know this whole thing is 12 squared to 3, which means this is 12 squared to 3. So when I add those together, I have 24. Square root of 3 is the base. The height is 12. And I divide that by 2. Well, 12 over 2 is 6. 6 times 24 is 144, I believe.
Yeah.
So that's equal to 144 pi. Or square root of 3, not pi. Okay. I think it was in the reading, and then she also did it as an example in the video. Here, what's the area of the sector? Well, the area of the whole thing is 64 pi, and that sector is a quarter of the whole thing. So 64 divided by 4 is 16. So 16 pi. Question 4, this was another example in the reading. The easiest strategy to solve this problem is to find the area of one of the blue sectors. I need to say multiply, not multiplying. Multiply by 4. False. The easiest way is to find the area of the whole circle and subtract the area of the square. You could do it this way, but that's harder than just finding the area of the whole circle and subtracting the square. Because to do it this way, we've got to find the triangle area, we've got to find the area of the sector, and then we subtract the 2, and then we multiply by 4. To do it this way, you just take the area of the whole circle and subtract the area of the triangle or the square, and you've got the area of all 4 of those blue highlighted areas. Question 5, the real-world problem at the beginning of the section involved comparing the area of a thick crust pizza to a thin crust pizza. That's true. Okay. Questions on this? Hardest part is going to be bringing Chapter 8 back, unfortunately. Because what if I had this triangle? Let's say this was 3 and this is 45 degrees. Actually, let's make it 30. Well, for me to find the area of the triangle, now I've got 15 here and 15 here, right? Well, this is not a special triangle that we know, so we have to use sine, cosine, or tangent to find the opposite and the adjacent. So all of Chapter 8 is going to be used in this section as well as the section tomorrow. So you may have to review those, that, you know, sine, cosine, and tangent, SOHCAHTOA, all of that stuff is coming back in. All right, that is it.